right, let's try some adding and subtracting rational expressions. Now, you've already done the multiplying and dividing. That's actually a little bit easier than the adding and subtracting. We'll do two kinds of examples. One where they already have a common denominator, because remember, to add and subtract fractions, you have to have a common denominator. And then we'll try one that they don't have a common denominator. So if you look at this first example, see how they both have an x plus 7 for their common denominator? Okay, that works out great. Then you can just add the numerators together and you leave the denominators the same. It would be something like if you were going to take 4/7 plus 1/7. That would equal 5/7. See how I add my numerators, but I leave my denominator the same. But I had to have the common denominator for that to happen. I've got it. So here's what I'm going to do. The one thing you have to be careful of on a problem like this is if this is a minus sign. That implies that you are subtracting all of this. So I'm kind of a fan of changing that to a plus the opposite. So I'll change that to plus, and I'll go in here and change all those signs. That way I'm sure to keep that minus sign on every single thing. All right, so then what I end up with is an x plus 7 for a common denominator over 2x plus 3 minus 4x minus 5. And then I combine my like terms on the top. The denominator stays the same. I have a 2x with a negative 4x. That'll get me negative 2x. I have a 3 and a minus 5. That's a minus 2. Okay, typically what you'll try to do is see if something reduces, but remember what we learned, that as soon as you throw addition or subtraction in there, that's a whole group, so I can't piece it apart really, only if I'm multiplying by something. The one thing that I could maybe do on this is if you look at the numerator, I could pull out a common factor. I would pull a negative 2 out of that. If I factored out a negative 2, I'd have a positive x and then a positive 1. And my goal would be to maybe get lucky enough that this quantity matches this quantity, and then I could cross them off. I didn't get that lucky, so I'm done. So either one of these answers, since it didn't help me to factor out the negative 2, this would have worked fine as an answer as well. However, if you didn't factor it out and it did happen to reduce, then it's going to be wrong because you haven't reduced it all the way. So it's worth looking at to see if it'll help you. Okay, let's try another one. Okay, now here's a problem where our denominators are not the same. Now this is really the problem you're doing, but I'm going to intro it with a little problem where it's just numbers. Don't worry about variables, and just refresh your memory. Remember, when you're looking to get a common denominator, you're trying to figure out what both of these numbers will go into. Well, 5 actually goes into 15, so I'm going to use 15 as my common denominator, and I just need to build this one up to match it. So I'm going to take this side times 3 times 3. So then I have 4/15 plus 9/15, and then I can add across the top. I end up with 13/15. Okay, let's try that with some variables. If I look at this, remember that anytime you have an addition or subtraction, that this is kind of its own thing. It's that whole quantity that we're dividing by, so it's kind of grouped together. Now, this addition or subtraction can't be separated with the division. So remember, multiplication and division undo each other. So if I want to ever do any reducing or anything, it has to be through multiplication. So don't try to do some reducing like with this x and that x or something, because this is tied up in subtraction. And in fact, this is tied up here and this is tied up here. The only thing that you might look to do would be to do some factoring. And in fact, there is some factoring on this one. I'm going to take, well, I was going to look at the numerator and I thought, oh, maybe there's a GCF or something that can come out of that, but there's not. But this one here definitely factors to two binomials. So we could call that x and x, 5 and 3, they're both minuses. Okay, so when I look at this, it's similar to what happened here, where I had kind of a single term that I had to multiply by something so it would match this one. Same deal. Look, this has an x minus 5, and so does this. But this one also has an x minus 3. And these are being multiplied. So what I need to do is I need to take this x minus 5 over here on the left and take it also times an x minus 3. Now those denominators will match, but I do it on the top also. So what I end up with then is a common denominator of an x minus 3 and an x minus 5. On the top, I'm going to take my 2 and distribute it. Plus, over here on the right side, there's nothing to do. I already had that common denominator. I'm just going to rewrite it. Okay, and then once you have that, you write your common denominator, and then you merge your numerators together through that addition. So I'm going to have this 2x plus this 3x. That's going to get me a 5x. And I'm going to have a negative 6 with a negative 19. That's a negative 25. Now the one thing that you want to do at the end is go ahead and take a peek and see if there's any reducing that can happen. And remember, like, I can't cross off individual things that are tied up in addition or subtraction. That's its own group. The only way to separate that would be to do it through factoring, like I did up here. I took these and I turned them into two things that were being multiplied. So that made these individual items. Well, if you look at this numerator, I actually can factor that. I could pull out a GCF. Let's do that. If I pull out the 5, I have an x minus 5 over x minus 3, x minus 5. And what's cool about that is I just created a multiplication situation here. And this quantity are identical. They're both being multiplied by something, so I could divide them out, and they actually will cancel and go away. Okay, that's pretty awesome. If that happens, it doesn't happen very often, but there you have it. So my final answer then becomes the 5 over the x minus 3. Okay, so let's try another one of these where the denominators are not the same. So we have to get a common denominator. This time I'm not as lucky as just looking at these and saying, oh, you know, one of them is fine and the other one's not. 5 does not go into 9, 9 doesn't go into 5. I've got to find a different number that they both go into. It would be 45. So what I'm going to do is take this one times 9 and take this one times 5. Now they're both going to end up 45s. So I have 20 45ths plus 27 45ths, which I can then combine to 47 45ths. Okay, let's try it over here on the right. Again, I cannot emphasize enough, when you have a plus sign, you got to put parentheses around it. Same thing with a minus. This is a whole group of things. This is a whole group. It would be so tempting to try to like cross that x out with that x. Cannot do that, not when they're being added. Okay, so what I'm really looking for here is a common denominator. And it's kind of like over here on the left where these were just two totally different things, so you just took them times the other one. Same deal here. This is an x plus 4, this is an x minus 2. I'm just going to take them times each other. So this side times an x minus 2, this side times an x plus 4. So what that's going to get for me is a common denominator of x minus 2, x plus 4. Now this we have a little bit more work on top. It looks like I'm going to end up trying to multiply these two binomials together. So that means I'm going to have to FOIL those. So to FOIL them, I'm going to end up with x squared. Outer is a 3x, inner is a negative 2x, and last is negative 6. Minus. Now let's do it on this side. X minus 2 and x plus 4 is the common denominator. And then I'm going to have to FOIL on the top. So it's going to be an x squared plus a 4x plus a 5x plus a 20. Now, one of the things that you have to recognize is that we are subtracting this entire fraction. So I don't get to just put that minus on the x squared and leave the rest of the same. I'm subtracting all of that. And I might have even changed it up here, but at some point you have to take that negative and turn it into a positive and change all the signs. So this is going to become a negative x squared. That shows the subtraction. This will be a negative 4x, a negative 5x, a negative 20. Okay, once you've taken care of that minus sign, then you're just looking to combine like terms. So the denominator stays the same. And then let's see what happens. We get our x squared and our negative x squared are going to cancel. We have a 3x with a negative 4x. That's a negative 1x. Oh, duh. Hang on. Let's combine more than that. I have a 3x minus 2x. That's a 1x. I have a negative 4x. Now I'm to negative 3x. And another 5x. That's a negative 8x. So when I combine all of the x's, I end up with a negative 8x. And then as far as numbers, I have this negative 6 and this negative 20. So that's going to be negative 26. Okay, last time I was lucky by factoring the numerator and seeing if something would simplify. So let's try this one. I could factor out a negative 2 on that. So let's do that. If I factor out a negative 2, I have a positive 4x and a positive 13. X minus 2, x plus 4. I didn't get as lucky this time. My resulting binomial doesn't cross off with either one of these. Remember, the negative 2 can't cross with that negative 2 because this one's caught up in subtraction. So I can only cross off entire quantities there. Nothing reduces. I've got my answer. That's it. All right. Good luck.